When should I shuffle in StratifiedKFold? I have read some posts on various CV approaches, but what I don't understand is why shuffling the data and the function leads to significant increase in accuracy and when it is correct to do it. In my time series dataset of size 921 × 10,080, where each row is a time series of water temperature of a particular location in an area and the two last columns being the labels with two groups, e. high risk high bacteria level in water, and low risk low bacteria in water, accuracy varies very differently based on if I set shuffle equals true, achieved accuracy of around 75%, versus accuracy of 50% when setting shuffle equals false in StratifiedKFold as shown below. The scikitlearn documentations states the following. A note on shuffling: if the data ordering is not arbitrary, for example samples with the same class label are contiguous, shuffling at first may be essential to get a meaningful cross-validation result. However, the opposite may be true if the samples are not independently and identically distributed. For example, if samples correspond to news articles, and are ordered by their time of publication, then shuffling the data will likely lead to a model that is overfit and an inflated validation score. It will be tested on samples that are artificially similar, close in time, to training samples. Some cross-validation iterators, such as StratifiedKFold, have an inbuilt option to shuffle the data indices before splitting them. Note that this consumes less memory than shuffling the data directly. By default, no shuffling occurs, including for the StratifiedKFold cross-validation performed by specifying CV equals sum underscore integer to cross underscore val underscore score, grid search, etc. Keep in mind that train underscore test underscore split still returns a random split. The random underscore state parameter defaults to none, meaning that the shuffling will be different every time fold shuffle equals true is iterated. However, grid search will use the same shuffling for each set of parameters validated by a single call to its fit method. To get identical results for each split, set random underscore state to an integer. I am not sure if I interpret the documentation correctly, and explanation is much appreciated. Besides, I have a few questions. 1. Why is there such huge improvement in accuracy after shuffling? Am I overfitting? When should I shuffle? 2. Given that all samples are collected from the same area, they are probably not independent. How does this affect shuffling? Is it still valid to shuffle? 3. Does shuffling separate the labels from their corresponding X data? Answer: update: no. Shuffling does not separate labels from their corresponding X data. THX.
Your question is quite tricky, and probably it is better placed here. In my time series dataset of size 921 × 10,080, where each row is a time series of water temperature of a particular location in an area and the last column being the label with two groups. Aren't you using a classification problem with time series futures? You are using dependent variables, time series of the water temperature, to predict a label. For me this sounds risky, and I would assume that there is not a good chance to predict the label. Just one scenario to think about. So in this example, label 1 is a time series which goes down and label 0 is a time series that goes up, but I would bet every classifier has a problem to learn it without connecting the trending component of your columns. To come back to your question, this can help you to understand shuffling. Difference between StratifiedKFold and stratified shuffle is split in scikitlearn.
When working with time series data, you are correct that shuffling will inflate the accuracy. The reason is because shuffling the training set will cause it to contain samples that are very similar to samples found in the test set. For example, if you trained a model from 2010 to 2019 and then predicted on 2020, all of the test set samples would be separate in time from the training period, so there would be no leakage of information. Now let's say that there was an extreme event in 2020 and you shuffle the data. The training set will now contain samples of that extreme event from some sensors, and then in the test set it will learn to predict a similar label for the other sensors during that period. This is a leakage of information between the training and test sets.